Hey guys, this is Mr. Grice for Algebra 2, Chapter 7.2 Notes, Day 1. Today we're talking about factoring quadratic trinomials by splitting the middle term. In previous sections, we learned how to multiply polynomials, okay? And we learned that by two different methods. One was the FOIL method. So there was FOIL, and that's where you multiply the first and you get x squared, the outside, the inside, and then the last, and then you combine your like terms. And when you combine your like terms, you would get x squared plus 11x plus 28. Okay, and now the other method that we talked about was the box method. Since we have a binomial times a binomial, you put 1 on the top, 1 on the bottom, and then you just multiply inside the boxes. X times x is x squared. X times 4 is positive 4x. X times 7 is positive 7x. And then 4 times 8 is 28. Combine your like terms, and you get x squared plus 11x plus 28. Okay, so there are two different ways that we've shown to multiply. All right, now we're going to work backwards and factor polynomials to find which factors were multiplied to obtain that result. So we're going to have the answer, and we're going to work our way backwards to find out what we started with. Okay. Now, to factor quadratic trinomials, such as, just an example, ax squared plus bx plus c, always check to see if there's a GCF. That's always the first thing we do. Identify what a, b, and c are. And then off to the side, we're going to do the factors of a and c. And then what two factors add up to b and multiply to ac. And what this is called is we're going to be splitting the middle term. And you guys might be like, whoa, Mr. Grice, that sounds weird. Let's just do a couple examples and then you'll figure it out. Okay? So the first thing we're looking at is there a number that I can take out or a variable from those three terms? No. So I want to know what my a is, what my b is, and what the c is. So a is 1, b is 11, and c is 28. So multiply a times c, and that is 28. So I want all of the factors of 28. So 1 and 28, 2 and 14, 4 and 7. So out of those two, which numbers add up to get to 11 and multiply to get to 28? What set of numbers is that? Well, let's check 4 and 7. 4 plus 7, that gives us 11, and 4 times 7 gives us 28. So we're going to split that middle term, so it says x squared plus 4x plus 7x plus 28. The only thing that changed was the middle. And if you were to combine your like terms, combine the 4x and the 7x, that gives us 11. So we haven't changed anything. So what we're going to do is we're going to draw a line down the middle, and we're going to take the factors of the two sides. Okay? So the factors of the yellow is an x, and the back is a 7. So when we pull out the GCF, we're left with x plus 4. And back here we took out a 7, and we're left with x plus 4. And that's good because that's our check right there. If we get the different answers right there, we did something wrong. Okay? now what we do, we write those two together and we get x plus 4 and the x plus 7 combined together to give us our other binomial. Now, if we were to factor or FOIL or do the box method, we would multiply and we would get that same answer. And that's how we would check. Okay? So our final answer is right here, the x plus 7, x plus 4. Right? Let's move down. So number 1, the directions say to factor each of the following quadratic trinomials. So for number 1, is there GCF? No. So we're going to multiply 1 times 18, which is 18. So 1 and 18, 2 and 9, 3 and 6. Which one of those numbers add up to 9 will multiply to get to 18? And they have to work for both situations. Okay, 3 and 6. 3 plus 6 is 9, and 3 times 6 is 18. So that's what we're going to split the middle term into. So m squared plus 3m plus 6m plus 18. Okay, draw the line down the middle and pull out the GCF of each one. So we get an m, and back here we can pull out a positive 6. So m plus 3, we pull out a 6 and we're left with m plus 3, which is good because, once again, that's our check. We want to make sure that those line up together. And then we get m plus 6. Put a box around it because that's our final answer. All right, number 2. Always checking, is there a GCF? Okay, the answer, no. So 4 times 3 is 12. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which numbers add up to 13 will multiply to get to 12? Can you find the combination? Okay, should just be 1 and 12. So we have to split that middle term in 4w squared plus 1w plus 12w plus 3. Okay, we're going to take the GCF of the front and then of the back. So the front is just a w. And the GCF comes out front, and we're left with 4w plus 1. In the back, we can pull out a 3. So the positive 3, and we're left with 4w plus 1. That's our check, which proves that we got the right answer. 4w plus 1, w plus 3. All right, number 3. Is there a GCF? In this one there is. Okay, you can divide everything by 2. So the 2 comes out front, and we're left with w squared plus w minus 6. Okay, so now we're going to do the same thing as before, where we multiply, and we get 6. So the factors of 6 are 1 and 6, 2, and 3. Which set of numbers add up to get to 1 will multiply to get to negative 6? Okay, it's 2 and 3. But one of them needs to be negative. And that's got to be the 2, because the 1 right here is positive. So when we split the middle term, we get w squared minus 2w plus 3w minus 6. I don't want to forget about that 2, so I'm going to draw an arrow and bring it down to the bottom. Okay, the GCF of the front is a w, so we're left with w and then w minus 2. And the GCF of the back is a 3. So it's a positive 3, and we're left with w minus 2, which is good, because that's just what we were looking for. W minus 2, w plus 3, and then don't forget about the 2. Okay, number 4. All right, there's no GCF. So let's see if you guys can start doing factors of 70 and see if you can find a pair that add up to get to 3, will multiply to get to negative 70. Go ahead and pause the video and see how you do. Okay, you should have gotten negative 7 and positive 10. Okay, remember when you're checking this, it's got to be true for both of them, and you can't change the numbers. So we get 2w squared minus 7w plus 10w minus 35. Okay, the GCF first is just a w. In the back, it's a positive 5. So we get w, and we're left with 2w minus 7. And in the back, we get a positive 5, and we're left with w, or 2w minus 7. There's the check. W plus 5, 2w minus 7. All right, go ahead and flip it over. Now, we're only going to do a couple of these together, and the rest of them you can turn in for extra credit. So let's start with number 5, or number 6. Is there a GCF? Nope. Now, why don't you guys go ahead and try, and you can see if you can get all the way through this problem. All right? Okay, just to make sure that you guys got the numbers, there you go. Go ahead and pause the video and see if you can work your way through the rest of it. Now, I did the GCF of the front, but now I'm looking at the back, and what can I take out? Well, your leading coefficient is negative, and we need that to be positive, so you can always take out a negative 1. And when you take out a negative 1, then we're left with 5w minus 2, which is what we got on the other side. Okay? So we get w minus 1 and 5w minus 2. All right, number 8. Remember, always check, is there GCF? No, no GCF. So go ahead and we're going to do the factors of 72. and the numbers that add up to -6 and multiply to -72. Okay, good luck. Okay, there's the rest of the work. All right, the last one we're going to do together is number 10. Now, looking at number 10, is there a GCF? For this one, yes, there is. We can factor out a 3. So the 3 comes out front, and we're left with 6x squared minus 11x plus 4. Okay, so I don't forget, I'm going to make sure that 3 comes all the way down to the bottom. Okay, and now factors of 24 and what add up to -11, but multiply to get to 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Well, 3 and 8 are the only ones that I know that add up to 11, and so both of those have to be negative. And if you multiply two negatives, you get a positive, so it works in both situations. Okay? So 6x squared minus 3x minus 8x plus 4. We can take out a 3x and a -4. Okay, so the 3x comes out front, and we're left with 2x minus 1. And then we factored out a -4, and then we're left with 2x minus 1, which is good, because those are the same. And then we get 3x minus 4, 2x minus 1. Okay? Now, if you want extra credit, you need to do 5, 7, and 9, and all of the homework. Okay? As always, if you have any questions, please come see Ms. Carranza or myself. Otherwise, that's it for Algebra 2, Chapter 7.2 Notes, Day 1. Thanks for watching.